Welcome to Eaton's Power Systems Experience Center. In this video, we will discuss supercapacitors and how they're used on modern power systems to give short-term ride-through, quick bursts of power, and supplement battery charging in electric vehicles and uninterruptible power supplies, as well as other applications. So what is a supercapacitor and how does it work? A supercapacitor is a very dense, double-layer electrochemical device. This large power module is made up of many smaller supercapacitors. Think of regular capacitors as parallel plates that hold a charge and are rated in microfarads. Farads measure the ability of a capacitor to hold electrical charge. The best analogy I've heard is that a supercap is like taking a sponge and cutting it down the center and looking at all of the parallel facets or plates that would be formed. Supercapacitors are very, very dense capacitors rated in farads. This one's rated 130 farads. Eaton Supercapacitor Group started in 1999. Most people haven't heard of supercapacitors as it's a relatively new technology, but used in many common products today. I remember my old professor used to get a kick out of himself sending students to the electronics store to ask for a 2 farad capacitor. He would laugh, but his joke wouldn't be so funny today because they actually do exist. In fact, we make some that are more than 3,000 farads. The other interesting thing about supercaps is that they're used to start trucks in northern Canada and Siberia. That's right, they aren't like regular batteries that are very sensitive to cold or even hot temperatures. Supercaps can operate from minus 40 degrees C to 80 degrees C, and they're physically smaller and lighter than their battery counterparts. Think of a supercapacitor as a rechargeable device like a battery and 100 times the power of a battery, but used for seconds rather than minutes or hours. A supercapacitor is like this larger faucet supplying a much larger volume of water quickly, but with a smaller storage tank compared to a battery with a larger tank but a smaller faucet. In many ways, changing from standard batteries to supercapacitors is just like changing your incandescent lights to LED lights. With lights, you go from 800 hours to 50,000 hours or more. With supercaps, you get a long maintenance-free life as you go from 500 deep discharges with batteries to more than 1 million with supercapacitors. In addition, you don't need to manage supercapacitors like batteries, so a BMS or a battery management system is not required. Finally, since they're made of simple, commercially available materials with no heavy metals, they're considered safer for the environment and require no special environmental precautions. Typical applications for supercapacitors today include replacement for batteries or flywheels in data center UPSs, semiconductor power quality ride-through devices, industrial applications, process equipment, healthcare imaging equipment, and transportation equipment. Today, as costs are coming more in line with battery systems, new microgrid applications also use supercapacitors for grid storage, frequency regulation, and solar firming applications. In short, supercapacitors are the perfect replacement if you need short-term ride-through to get you through deep sags or short-term interruptions like recloser operations. We put supercapacitors on a ride-through device called a drive ride-through or DRT attached to the DC bus on a variable frequency drive in an oil and gas application. They had a payback of less than 2 months as 1 to 2 second interruptions from reclosers clearing lightning strikes caused 8 hours of downtime on progressive cavity pumps. In addition, they're perfect for anyone who's considering replacing batteries with a flywheel device to give short-term ride-through, 10 seconds or so, just enough to get the generator started. Flywheels tend to be heavy, noisy, and require significant maintenance, where supercaps are light, quiet, and require no maintenance. Here at the PSEC, we have a great demo set up to show how supercapacitors can be used as a battery replacement for 93 PM and 9395 UPSs. This is a 93 PM 100 kilowatt unit with two 50 kilowatt power modules. We've attached 8 of these supercapacitors to the DC bus via the same breaker you would attach a string of batteries to. Each of these supercap modules is rated 130 farads and 62 volts. We'll operate at a DC bus voltage of 480 volts. The supercaps are fully charged, and we will apply a 40 kilowatt or 40% typical load and then kill the power and watch as the supercaps discharge. Okay, here we go. Initiate the test and start the timer in 3, 2, 1, go. Watch as the supercaps discharge and continue to feed the load for more than 15 seconds. Okay, now the power is back on, and watch as the supercaps recharge very quickly. In fact, in comparison to batteries, supercaps are super fast at recharging. For example, with lead-acid batteries, a 10-minute discharge takes 10 times 10 minutes or 100 minutes to get back to 80% charge, and then another 10 times that to get back to 100% charge, or almost a full day. With this demo, we can show how easily supercapacitors can be integrated into your system. While UPSs and other ride-through devices have been used for years to provide backup during power disruptions, there's another option that you should consider for your system: supercapacitors. For more information about Eaton's supercapacitor options, please visit our website. Here at Eaton's Power Systems Experience Center, you can see firsthand how supercapacitors work and what you should know if you're considering applying them for your application. Contact us or your local Eaton representative to schedule a visit to the Power Systems Experience Center today.